Hello, everybody, and welcome to the webinar Planning and Building Fiber Network Rollouts in Europe. In this webinar, we will focus on the end-to-end workflow of a fiber rollout in Europe, from planning up to building the network. It's strange times these last couple of weeks, and we see that a lot of people are working from home. But for some, this is easier said than done. In more remote areas, people don't always have the best internet connection, and that's why we see that some European authorities are boosting fiber deployment in these rural communities in the form of funding programs. Of course, these programs go hand in hand with restrictions and obligations regarding the deployment. In this webinar, we want to show you how you can make it easier for companies involved and organizations involved in these projects, how to make it easier to comply with the challenges of such programs. This webinar is a joint presentation from TKI and Comsof. At Comsof, we created Comsof Fiber. This is a GIS-based fiber network planning and design software. We have been developing this tool for over 20 years, and because of our knowledge, our tool is used in over 50 countries. More than 100 million homes were planned with the help of Comsof Fiber. That's why today we want to share some of our experiences in Europe with you, and I'm joined here by our partner company, TKI.
So TKI is planning and building broadband networks for 30 years and is providing GIS-based planning and inventory software for almost 20 years. The core product TKI Net is used by engineering companies and network operators all over the globe. Comsof and TKI have been partners for over 10 years. Our joint solutions have been used to pass dozens of millions of homes. In Germany alone, more than 30 of our joint customers plan and build networks under the German Federal Broadband Funding Program with the help of our software. Your presenters of today are Jonas Verstuyft from Comsof. He is the product manager for Comsof Fiber.
And from TKI, we have Thomas Köhler. He's the head of software at TKI. Now, before we start the webinar, we would like to know a bit more about you with a short poll. And the poll is about the fact how you are involved in publicly funded fiber rollout projects. And if you are involved in these projects, how is that? So now I'm gonna start the poll here and give you a couple of seconds to answer. So yeah, just want to know, are you involved in these kind of projects? How are you involved in the planning stage, building stage, more in construction monitoring, supervision, or are you more liaison between the rollout and the funding body, or are you not involved at all? Even if you're not involved in funding projects, this webinar will still be relevant for you. Just want to get an idea of the kind of audience we have today. Seems like answers are coming in right now. Just give it a couple of seconds and then I'm gonna close the poll. All right, let me quickly share the results. So what we're seeing is that yeah, 1/3 of the audience is not involved in projects, but yeah, a lot of people are involved in the planning stage, building stage. So this is definitely, I mean, you're definitely in the right webinar here to learn more about our solutions for these kind of projects.
So when we look at publicly funded projects, we see three main drivers that lead to an increase in complexity. So first is special design rules, for example, regarding the amount of fibers to bring to the customers, the type of ducts to be used, or regulations about spare capacity to foresee in our designs so that a future-proof network is built that can be extended in the future. So here's an example from Germany, from the German federal funding program, a uniform material and sizing guideline that needs to be complied with. Second is documentation obligations. Again, an example from the German federal funding program regarding the duty to document the network built with photographs. This little text here says that any active and passive equipment, as well as the open trenches, need to be photographed, and it is 3 times, first before, then during, and finally after the build activities. And all those photos need to be provided to the authority at least once a year. So you can imagine that quite a lot of pictures will be collected here. And the third point is special data formats. So after reaching certain milestones, the progress of the rollout needs to be communicated in specific data formats, just as a proof of delivery. And that's one of the main conditions to get the funds paid out. And again, we have the specification here of the German program, which is called GIS Nebenbestimmungen, so the GIS guidelines. You see there is a version 4.0 already from 1st August 2018. In the meantime, they published a version 4.1. So there's also evolution happening in those guidelines. Another example would be the French GRAS THD format, which is based on an initiative of a lot of municipalities and companies in France. And just a little insight into those formats. The German format defines 4 different phases of the rollout and a set of, in total, 9 layers that need to be provided to the authority either as shapefiles or in the GeoJSON format. And the French GRAS THD format is even more detailed. Here we have 9 phases and in total 33 different layers that we need to maintain, populate, and finally hand over. So we believe that in today's competitive environment and with the extra implications of funding programs in mind, only the following ingredients enable you to deliver successful and quality projects. First is efficient design processes. The sheer amount and scope of current fiber to the home projects require modern and also highly automated approaches to network design. The project data, and that means all project data, needs to be available to all relevant stakeholders at the right time within a seamless and integrated tool suite. So you don't want your people work with emails and file storage in some hidden folders. And you need to have the flexibility in your processes and in your tools to dynamically adapt to the evolution of public guidelines and requirements. We had seen it on the previous slide. There's already version 4.1 of the German guidelines.
All right. So Comsof and TKI cover the complete network designs and build workflow in an automated and integrated way. And we just want to walk you through the different steps in such a workflow, very high level now, and then go into some more detail, and then go over to a demonstration of the integrated solution. Now, a project typically starts with strategic planning stage. So in this stage, you need to make a go, no-go decision for your project. And you will require accurate cost insights and information to maybe reply to a public tender. Typically, there's quite some time pressure, but you need to come up with accurate numbers where, that you're confident in that you can realize the project for the calculated costs. And here, automated design, cost calculations, and cost calculations give you this accurate information, give you the confidence to reply to the tender, make the decision to move forward with the project. Now, after winning the tender, you can start the project to roll out the network, to design it and roll it out eventually. This starts with an initial design phase. And in this phase, you need to determine how to connect all of the homes in the project, how to route the network, which equipment to place, and where to put it.
So this initial design is then verified in the field. Your input data will be in constant flow and underlying constant update. So there are maybe new housing projects that are discovered and need to be included. Address data is undergoing constant update and correction and last minute changes. And your network design needs to be adapted accordingly all the time. And imagine that far in the process, you need to move the POP location from one edge of the area to the other. No need to worry. You don't have to spend weeks of work to redo everything. Instead, our software algorithms will calculate a new best network based on the changed conditions in a matter of minutes. Then ROW permissions are requested, cabinet locations secured. When the design reaches field-proof stage, automation will step in again and help creating all necessary construction documents and job packs so that we reach the to-build plan stage. During construction, all as-built changes can be documented in the same tool environment, leading to a full topologically correct inventory of the assets in the end. And this is where the network operation begins and the end customers can finally get to use their new broadband connection, while the operator can remain using TKI Net for day-to-day inventory and operational tasks like fiber routing, service, and outage management.
All right, so let's look at the design phase now in a bit more detail. In this phase, like I said, you want to determine how you connect all of the homes in the project area. How do you route your cables? Which cables and ducts do you place? And how to aggregate fibers at structures like cabinets or manholes. It's important that the design, of course, follows the rules set out in the funding program. So you need to be able to follow those rules in this design stage. Now, to do design with Comsof fiber, you need basic geographic input data, address locations, the green dots that you see here, and street center lines. That's all you need for a greenfield build. We can, of course, also plan aerial networks or reuse existing infrastructures like ducts or existing cables. Then, secondly, you need to set up your design rules. So with the software, you configure the architecture that you want to use. You specify the material, the civil works, and enter the cost for material and labor as well. Out of the box, we offer a wide variety of configuration settings. This is all based on the experience in over 200 projects worldwide, and we keep extending the functionality here. I'm not going to go in detail here in the rules now. In the demo, we will highlight a couple of settings of the design rules. If you have specific questions about architecture that we support or how the rules work, you can always ask a question via the GoToWebinar window or contact us to follow up one-on-one later. What's useful about the design rules, of course, is that you set this up only once and you can reuse this same configuration for every project that you do that is using the same design rules, same architecture. Now, based on the architecture provided, the software will determine how to route the cables in your project area. Then the user, like Thomas said, can then go in and make changes based on field survey input, change routes, change structure locations. All of that is supported. Now, The software, of course, is working cost-driven, so it's using the cost information that you provide in the design rules to come up with cost-effective, cheapest routes to connect all of the homes. While doing so, it takes into account the reuse of existing infrastructure and the cost tied to doing new trenches versus reusing that infrastructure. The software will also automatically determine which cables to use, which ducts to use, where to place all of them, and where to aggregate the fibers in a cabinet or a manhole. What you see here, the labels indicate which ducts are used on each segment of the network. Then what will also automatically be calculated is a bill of material. And there we provide you a detailed breakdown of all the equipment, all the civil works that are needed to actually roll out the network, which gives you a high level of confidence also already in the strategic planning stage.
So then the next step would be to create the to-build plans. So the construction documents, the splice and blowing lists and the like. So everything that the field teams need to efficiently build a consistent network, consistent infrastructure. Again, you start by setting up your rules, this time for those detailed design rules. This includes unique, meaningful identifiers for all objects in the network so that the construction teams can relate the objects that they see on the plans, and splicing rules as well. So detailed rules for how the splice closures and the ODFs should be equipped. The software will apply these rules to your design, and the result will look like this as an example. So we have here the same area, some identifiers that we can see on the distribution points and all the connections, and splice plans as well, just as an example. During all stages of the rollout, our NetMobile solution ensures that the field teams and the back office workers always stay in sync. NetMobile is our mobile GIS client that serves field survey and photo documentation use cases. And now let's have a closer look at those procedures in the actual application. So for our demo today, we brought a real-world project from the city of Plauen in Saxony, Germany. Plauen has about 65,000 inhabitants, and our project here is about bringing broadband internet to approximately 3,100 households that currently have less than 30 megabit per second, because that is the main condition of the German federal funding program. In order to begin with the design, we first need to load our input data here using the import button, and I'm going to show you what we got here. So we have address points, we have some existing duct information and the possible trenches, so the options for the software to actually place our infrastructure. So what we see here is that our target addresses are located in the northern outskirts of the city, in the more rural parts. That is to be expected, because most of the projects under such funding programs will be located in the rural areas. So we got the input data. Let's maybe have a quick look at the existing pipe that we see here in the center. So I just double click on it to see we have a DN110 duct of 680 meters. So it would indeed be nice to reuse that for our design. The next step after loading the input data would be defining our design rules, and for that I'm going to bring up the Comsof Fiber Designer Rules Wizard. The Rules Wizard is structured by network layer. I'm definitely not going into all the detail and all the flexibility that we have in here today. That would be for another session. Instead, I would just like to highlight a few key aspects, a few key settings for our project at hand, according also to the German federal funding program. So first and foremost, what do we want to build? We want to build fiber to the home compared to fiber to the building. So every apartment should get their own fibers, and we want to build a point-to-point network, no splitters in this case. Let's move over to the demand section, where we'll see that every single apartment will be connected with 4 active point-to-point fibers, and there will also be a spare capacity of 2 fibers per building, and this is to comply with the rules of the funding program. On the distribution layer, we will notice that we'll use a direct cable to the building strategy. So from the DP, we will have individual connections, individual cables per each building. Our distribution point capacity will be 40 cables, and as is very common and very typical in Germany, we use microducts to bring the cables to the customers. So on the distribution layer, we work with 7-way and 12-way duct bundles, where we keep 2 ducts or 2 microducts spare in the 7-way and 3 microducts as spare in the 12-way duct bundle. And this is again to comply with the rules of the funding program. We also have material and labor cost settings in here, and this is relevant for the software because the software will use these settings to decide on which duct to use per trench. So let's move over to the feeder layer. On the feeder layer, we also use a direct cable strategy. So again, individual feeder cables per distribution point. Of course, it would also be possible to daisy chain, so to connect multiple DPs with the same feeder cable, or it's also possible to have a ring protection planned by the software. On the feeder layer, we also work with microduct bundles. So here we have the 7-way again with our 2 spare microducts. And we have checked the use existing pipes where possible option, because for feeder we want to place the feeder ducts in our existing pipe. And in this project we also have a backbone layer, because we have multiple POP locations that we want to interconnect, and that's where the backbone layer comes into play. Again, using microducts, 3-way duct bundles with 1 spare microduct in this case, and we also want to use our existing pipe when possible. So with the input data loaded and the design rules defined, we can start an actual calculation. So we will not focus on those buttons here, which are for data pre-processing, but our project is already in the field proof stage, so we could directly start a calculation. Takes about 2 to 3 minutes for this area. I'm gonna skip this and show you the results right away. So I'm switching over to another display map, and then we can zoom in and have a look. So the red lines now represent the trenches that the software has chosen, and we also get some annotations alongside telling us the type and the amount of ducts that the software has placed in there. And what we see here is a full topologically correct model of the network. It's not just a plan of some simple dump lines. Everything's connected, everything is stored in a database, and what that means is we can again bring up the attribute form of a trench, of a connection, and see what's going on in there and see what is linked. So this trench that I now picked carries a 12-way duct bundle, another 12-way duct bundle down here, and a 7-way duct bundle, and we also got the cables inside of these duct bundles as part of the result. So besides this full model of the network in a geographical representation, we also get a bill of materials in Excel format, which gives us a cost breakdown and overview of the area with the total cost per connection, as well as a detailed list of material and services according to our design rules, configuration and cost settings that we specified. Now, one important point that I want to make here is that we see our software as a tool to make the planner's job more efficient and allow the planner to focus on the critical design decisions, like where to place locations, where to place distribution points, where to place a POP, how to route cables, so which routes to take, how to aggregate addresses to a distribution point, decisions like this, instead of drawing lines day in, day out, compared to, or like in a more traditional manual planning procedure. So what does that mean? That means that the planner has full control. For example, if we wanted to move those 3 connections here to this distribution point, so the blue square represents our distribution point, the polygon the feeding area of the distribution point. So if we wanted to bring those 3 connections to this DP, we would just change the polygon accordingly, run a new calculation, and the software would then place the ducts and the cables for us according to the new input that we specified. So instead of manually redrawing everything, we click the button of calculation and get a result in a matter of a few minutes. And the sample that I had shown now is a simple scenario, but imagine you have to move the POP from one edge of the area to another edge, and the impact that would have on your design. Here you first hide the label to make it more clear what you want to say. You pick the location and then move it accordingly. So now I picked the DP, so I would typically move it inside of the cluster, but the procedure works the same way for the POP. If required, you can move it to a completely different location, rerun the calculation, and the software would then do the dirty work for you. And you, more importantly, get a new result in a matter of minutes compared to a matter of weeks before in the traditional planning process. So key takeaway here is our software is a tool to the planner, but the planner has the full control over the design. So now we will go into field survey. We would verify the routes until we reach the field-proof design, and then we do a first handover to the public authority to apply for our funds. So we use the export button here, select the BMVI export, in this case for the German program, select the output directory, the version interface. Versions will evolve. That's an important lesson learned. We click export, and as a result we'll get a set of shapefiles, in this case, that we can take and upload to the website of the public authority. And then our project goes into the grant approval program. And once we got the go that we can build the network, our next step would be to produce the to-build plans. For that, we use the Create Low-Level Design button here, where we select our field-proof design and the destination to-build target database, as well as our settings for splicing and naming, where we again have a lot of flexibility to cope with all kinds of different rules. So this procedure will again take 2-3 minutes. I'm gonna skip that and move right over to the results instead to show you what we will get from this transition. So let's zoom in here to the same area again, and what we will see are unique identifiers per connection, unique identifiers per distribution point, as well as some color coding that has been applied, because in this particular project the duct bundles, they also get colors, so the outer sheath of the duct bundles will have a color, and that's represented here in those labels along the trenches, also the labels of the actual connections represent the color of the duct bundle where this connection is fed from. Besides those unique identifiers, we also got splicing information based on our rules that we specified. So when I select this DP here, we see that 220 splices have been created in 19 splice trays. And to get a more visual representation of that, I'm bringing up a schematic splice plan where we could then trace every individual fiber and see how it's connected. This is handy for verification in the back office. The field teams, the splice technicians, they would get tabular reports in the form of PDF files that we can also create with the software. Now, in an ideal world, we would just create all those construction documents, handed out to the technicians, and would be done. Unfortunately, yeah, we don't live in an ideal world. In many projects, we will get last-minute changes, last-minute updates. Maybe there's some other construction work going on in the road, and we need to move to the other side of the road with our trench, or there are some additional connections that have been identified that we need to include in our design. And TKI Net has you covered for all these scenarios. We provide a variety of different workflows, wizards, and functions for adding additional connections into an existing duct network, for creating splice records. All these kind of tasks are covered in here. By the way, don't worry about the German strings. It's a German project and our colleagues work with the German version of the software, but of course everything is fully localized and you can also get it in English. So all these last-minute changes are incorporated into the design using the TKI Net workflows, and then we can finally create our output documents. For that, we have a feature that we call the doc pack. It consists of two pieces or two components, the configuration and the output. So the idea behind is that you do a one-time configuration of the types of documents that you want to deliver for every single project that you do. So typically this would be construction drawings, blowing lists, splice plans, and maybe others. So you configure that one time, and then for every instance of a project that you do, you just apply this configuration. So if for this example here, we have defined 4 different types of outputs that we want to be created. We have an overview plot, we have the detailed plots, and then some splice reports and splice plans. So for this project, we will get that amount of files as mentioned here as PDF files. Next step would be to click Start, wait, and have all those PDF files be created for us. And now I'm going to show you a few examples of this very project here in Plauen, what is used there. So some permission drawings, right-of-way drawings. You see all the sheets that have been created. And just one example. So permission drawing doesn't contain a lot of interesting stuff, just where we want to dig. We also got the cabinet location permission drawings, where we indicate where we want to place the cabinets, and then to build plans like our construction drawings, which look very similar to what we had seen before on the screen. Again, detailed title block and legend in there explaining everything. And besides those construction plans, we have build lists, which contain duct blowing information, just detailed information where every duct leads, which building is connected by which duct, and also splicing information. So again, these are just some examples that the software can produce automatically. There's a variety of other schematics of reports, There's also a report designer where you can customize reports according to your needs. So yeah, a lot of different outputs that we can produce to satisfy the needs of all the stakeholders of the project and to deliver meaningful and accurate information to the construction teams. Then in the actual construction phase, we will get as-built information back from the teams. So sometimes they might have made the connection a bit differently, maybe swap the microduct order or swap the fibers, and we can use the same workflows, the same wizards again, to incorporate all these as-built changes into our database over here. And once everything is done and properly documented, we would do a final handover to the public authority. And this time the dialog looks a bit extended. We have a few more options. We have more faces available because the level of detail we have in here is much more than before. So we do the final handover from this. And by the way, the level of detail is so accurate that you could use the same database and the same tool for the following operation of the network. So fiber trace is possible. You can manage your outages. You can manage your services. It's all in there, and we'd be happy to show you more in a separate session. And with that, I would like to hand it back to Jonas for some closing remarks.
Okay, so to wrap up this webinar, I want to just go over a couple of key takeaways that we want you to learn today. First of all, related to the European funding challenge. So, like we said in the presentation, there are certain rules and obligations that are tied to these programs. What you want is you want your tools to help you overcome these challenges, make your life easier. And what we wanted to show you today is that the joint solution of Comsof and TKI can help you to comply with specific design rules, with the data formats that you need to deliver the designs in, any documentation requirements. So our tools can help you with these challenges. Next, our solutions are completely integrated from planning up to build and documentation. So there's no manual handover of data between the different stages. So by automating that handover, by integrating closely, you cannot make any mistakes. So when Excels would be flying around or files flying around from one division to the other, that's where a lot of mistakes can be made. So we avoid this by having a smooth workflow and handover of data. And finally, software automation. Automation is key in this whole process. So our solutions are powered by this automation to generate the design, to create all of the necessary documents. I think the benefits of this are clear. So you avoid any errors. When you're designing a network manually, it's easy to make a mistake. It's easy to overlook some mistakes in the design, foreseeing a cable that's too small maybe, or link the wrong fibers when you're generating two build plans or creating them in Excel. By using design automation, you also get consistent results. So within these funding programs, you have certain architectural rules that need to be followed, design rules that need to be followed. Also maybe, to build plans, you want them styled in a particular way, and each time you want them to look the same, so that the rollout, the operation of the network just goes smoothly. And I think most obvious benefit of automation is that it saves you time, it saves you money. When it comes to design, processing, survey feedback, generating the two build plans. All of this can take up a lot of time. Often it's also quite repetitive to do. And I think with our integrated solution, you can enjoy the benefits of automation. Let the software do the dirty work. Then I think also what I wanted to highlight is that the automation is cost driven. So it's a certain optimization in the design, which allows you to build cost effective designs, which can be very valuable, definitely for these publicly funded projects, which are often in rural environments where more trenching is needed. It's beneficial to use design optimization, automation to come up with a cost-effective design. Now, we've come to the end of the webinar. I want to open the floor to the audience to ask questions via the GoToWebinar window. It should be located on the right-hand side of your screen. If you have any questions, please go ahead and ask them, and we'll answer a couple of them right now. Let me have a look here. Okay, so one question I want to go in is, can both tools be used separately? So what we presented today is it's an automated solution. So Comsof Fiber together with TKI Net. It's very powerful when used together. Everything is completely integrated. So you have a smooth workflow. But both tools, both solutions are also available standalone. So yes, they are available standalone, but yeah, integrated they are much stronger and help you a lot more in your project. Second question I want to take here is, can I load in existing poles and reuse them? So I quickly highlighted that during the presentation that we support aerial deployments. So if you have existing pole infrastructure, which you have yourself or which you lease maybe, you can load them into the software and reuse them for an aerial deployment. We also support the loading of other existing infrastructure, like maybe you have existing pipes, existing ducts with available capacity, or have fiber cables laying in the ground which you want to reuse. That's also possible to do that with the software.
Okay, there was another question on the mobile client, whether this tool can be used for street and site survey. And the answer to that is yes, absolutely. So that's one of the main use cases that we currently see of the mobile client. And maybe a bit related to that question, are the construction teams supposed to work with the software directly or just hand in the revised plans? So currently what we still see a lot is that in the field, people, especially the construction teams, need their paperwork, make their redlining there with a pen and hand it back to the office. So that's, yeah, we're working on improving that and digitizing this process as well, but it's not just a matter of the right tool. It's also a matter of perception and of being used to the new way of working. So this one of the areas where a lot of development and a lot of investment is happening at the moment from us to make the construction site more digital. Maybe one more question. When using TKI for detailed design, is there a way to export this detailed design into a third-party inventory or documentation tool? So that is a common scenario of some of our customers, and we have established integrations with a variety of tools like Network Engineer, like Esri ArcGIS, a couple of German tools that we integrated with, and we also ship the software with a well-documented XML format that our customers can use to build integrations on their own.
There's maybe one question that I want to take here. Is it required to have a GIS map of the area to start designing? So what you need to start a design is you need some GIS data. You need address locations. You need to know how many homes there are, so that you can foresee the connectivity. And you need to define the routes that can be used. And we can use street center lines for generating new trenches, new possible trenches that can be used in the design. So like I said, that's the basic input data. So that's data that that needs to be acquired. There are some open source locations where you can gather that information from OpenStreetMap. Data can be gathered, but there's also data suppliers that can be used, or you can collect the information in the field or from satellite imagery as a starting point. But when it comes to the actual design, of course, you need to know exactly where you can do trenching, where you want to do trenching. You need to know how many apartments or homes there are inside of the building, so that you can come up with a correct design. So that's information that needs to be there. Either it needs to be enhanced or it can be purchased, but that depends. Region by region, country by country, there are different sources available where you can get this information. Maybe we can conclude the webinar here. There's still some open questions, but we'll follow up one by one via email. What I can say is that we will share a recording of this webinar, so that you can share with colleagues that might be interested or want to rewatch part of it, part of the demonstration maybe. So that will be made available. I want to thank you for watching the webinar. There will be a short survey after we close the webinar. So if you have just a couple of minutes to fill that in, that will be very helpful for us. I hope you enjoy it. I hope you stay healthy in these strange times, and have a nice day. Thank you.
Yeah, thanks from me as well. Appreciate your time for watching today. Take care and goodbye.